Hello, everyone, and welcome to Algebra 2. This is section 7.1 on inverse variation and 7.2 on graphing rational functions. So, two variables, x and y, show direct variation when y is equal to a times x. That's the equation that you're going to want to know. That means that two things are both either increasing or both decreasing. So maybe the more you study for a test, maybe your grade goes up. It may not show direct variation, but certainly they're both going up. If it goes up at the same rate, then we call it direct variation. Inverse variation is when one thing goes up and the other thing goes down. And this is the equation that we will use for inverse variation. An example of that might be something like the more miles you drive on your car, the less gas you have in your tank. And we call A the constant of variation. So while you can say if two things are going up, they might be direct variation, there actually is a way to tell. If you divide y by x and it always produces the same constant, then x and y vary directly. If you multiply x and y and they always produce the same constant, then x and y must vary indirectly, and not just one going kind of up and one going kind of down, but they actually have indirect variation or inverse variation. We'll do some examples and you'll see. So I'm looking at number 1, and x is definitely going up and y is definitely going down. So my thought is it could be inverse variation. So I'm going to do x times y for each of them. This is 24. This is 24. Oh, this is looking good. And this is 24. So I have just found the constant of variation. It's inverse variation because one's going up and one's going down, and there's my constant of variation. I look at the next one, number 2, and I see that x is going up and y is going up. So it can't be inverse variation, but I can look at direct variation. And this is y divided by x is always going to give me the same number. So 2 divided by 1, 4 divided by 2. This one's looking good. Oh, 8 divided by 3. And then 16 divided by 4. So yes, x is going up and y is going up, but not at the same rate. So I already knew it wasn't inverse variation, and now I know it's not direct variation either. So it's neither. Number 3, I see x is going down and y is going down. So it could be direct variation because they're doing the same thing. So I'm going to do my y over x again. 20 divided by 4 is 5. 15 divided by 3 is 5. I'm not going to get my hopes up because last time they were dashed. 10 divided by 2 is 5. And it does work. So it is direct variation. In my equation, I've just found my constant of variation. So we write that as y is equal to 5x. I didn't actually show this one. This is inverse variation. All right, you should probably try number 4 on your own. But of course, I am going to do it for you. X is going up and y is going up. So if it's going to be either direct or inverse, it has to be direct. I do my y over x. Excuse me. And I get 1 divided by 1 is 1. 2 divided by 2 is 1. 4 divided by 3 is close to 1. It's 1 1/3. And then 8 divided by 4 is 2. So it is neither. All right, let's do some more complicated problems. The variables x and y vary inversely. All right, first of all, as soon as you see that, you want to write this down. Y is equal to a over x. That is your equation. And then it says, and y is equal to 4 when x is equal to 3. So last time I had an entire table because I was checking to see if it was inverse or direct. This time I'm telling you it's inverse. I only have to give you 1 point for you to figure out what that is. So I can just plug them in. 4 is equal to a over 3. So of course I clear my fraction, multiply both sides by 3, and I get a is equal to 12. So writing an equation that relates them is going to be 12 over x. And then it says, find y when x is equal to negative 2. So y would be 12 over negative 2. Y would be equal to negative 6. If you understood that, you should probably try number 2 and maybe even number 3 on your own. The variables x and y vary directly. As soon as I see that, I write my equation. Y is equal to a times x. And then I need to find this a, but they've given me points, so now I'm going to fill them in. 20 is equal to a times 10. A is equal to 2. Now, when this says write an equation that relates x and y, you can't stop here. I actually want the equation. So the equation is y is equal to 2x. Then I can use that equation to find y when x is equal to 8. Y is equal to 2 times 8. Y is equal to 16. Okay, really, now, if you have still not stopped this video, you should on the next one. The variables x and y vary inversely. Y is equal to a over x. But I need to find a. When it says write an equation that relates them, a doesn't count. You need an actual number there. So I'm going to use this and plug it in. So 3 is equal to a over 1. So a is equal to 3. So my equation is y is equal to 3 over x. And then when x is negative 9, y is equal to negative 1/3. So how are these used in a problem? Well, let's think about all the possible dimensions of a rectangle with an area of 24. So how could I draw that? Well, probably the first one that comes to mind is a 4 by 6 rectangle. But I could make it a 2 by 12 rectangle. Or I could make it a 1 by 24 rectangle. Or I could even make it a 3 by 8 rectangle. So many choices, right? So are the lengths and widths directly or inversely proportional? Well, hopefully you can see that if I want to make this length bigger, I had to make the width smaller. Why? Because they had to multiply together to make 24. This is a classic example of something that is inversely proportional. So what's our equation going to be? Y, or maybe we should say length, is equal to sum A over width. And then look what's going to happen. A is equal to, clear the fraction, L times W, which is the formula that we know. And in this case, A is 24. So I guess they didn't actually ask you to write an equation, but hopefully that makes sense. Number 2, does the time that it takes a group of roofers to roof a house vary directly or inversely with the number of roofers? So before you even start, just think about that. If you have more roofers, is it going to take more time to do the job or less time to do the job? So if you only have one person up there roofing, it's going to take a long time. But if he gets 4 or 5 buddies to help him, they might be able to do it faster. So we're looking at inversely here. So it says, given that it takes a group of 4 roofers 9 hours to roof a house, write an equation that can be used to determine the time it takes to roof a house as a function of the number of roofers. So a function of the number of roofers, that's what we're looking for. So since it's inversely, I'm going to write y is equal to a over x. But in this case, I want to change that to the time is equal to a over the number of roofers. So I put in the one that I was given. I was given 9 hours is a over 4. And I can multiply that to find out that A is equal to 36. So the time is equal to 36 divided by number of roofers. Make a table showing the time that it would take to roof a house. So here's the number of roofers is 2, 6, 9, and 12. How long would it take? So using this equation, T is 36 over N. If N is 2, it would take 18 hours. If you've got 6 men working, it's only going to take 6 hours. If 9 people are working, it's only going to take 4 hours. And if 12 people are working, it's only going to take 3 hours. So this next section is where we begin 7.2 on rational functions. You'll see that the word rational has the word ratio in it. So a rational function is just a function that's the ratio or the fraction of two other functions. And they're always going to have a graph that has this unique shape, which we call a hyperbola. It has two symmetric branches. So this is one branch, and then this is the other branch. And it has an asymptote. So an asymptote is, that P is silent, just asymptote, is like a guideline. We usually make it dashed, and you're saying the graph is going to follow this in the end. The graph follows horizontal asymptotes. In the end, it only tells you about end behavior. So you can see that in the middle here, it doesn't follow the asymptote at all. But at the ends of the graph, it follows it. And then there's also a vertical asymptote. The vertical asymptote is more like a wall that you never cross. So think of it like the graph is going along, having a perfectly good day, and then all of a sudden it's like, boom, there's a wall there. So it's like, okay, I'll just walk down along the length of the wall, but you can't go through the wall. Same thing over here. The graph is going towards the wall, and when it gets to it, it can't go through it. So it just goes up and it just follows the wall, but it can't actually go through it. We'll graph some of these and you'll see how it works. So of course, whenever you have a function that's new to you, you can just plot points. So what do we usually start with? 0. You can't plug in 0. You can never divide by 0. And that's what creates the asymptote. So I'm going to put a wall there. I'm going to put a vertical asymptote there, and that says x is never equal to 0. So the vertical asymptote is this line, vertical line, x is equal to 0. Remember, all vertical lines are x is equal to a number. And then we can plug in 1, and I get 4, 2, and I get 2, 3, and I get 1 1/3, 4, and I get 1. And that should be enough. And then 2, 2 at 3, and 1 1/3, 4, 1. And see, can you see that shape that it's making? So even though you can't see it from the equation like we could with the vertical asymptote, you need to know that there is a horizontal asymptote. So this graph is going to come down, go through these points, and then it's going to follow that horizontal asymptote. Now, because there is another branch, you do have to plot points on the other side too. So at -1, it's -4, and you'll see this symmetry there. And then at -2, -2, and then I'm going to skip that 3. That wasn't a nice point to plot. So at -4, -1. And that's how I can get that branch right there. So my horizontal asymptote is at y is equal to 0. My domain for this problem is x is not equal to 0. The vertical asymptote and the domain are always going to be related. So the vertical asymptote tells you the equation of the line. That's why it doesn't have a not equal to sign. That is the equation of that line. The domain tells you what x can't be. X can't ever be 0, which created the asymptote. So that's why they're always related. And the range it goes all the way up and all the way down, but y is never 0. So again, y is not equal to 0. So these two are going to be related. All right, you should try these on your own. You'll notice that this section on asymptotes, domain, and range is just listed once in the center of the whole paper. That's because it doesn't change until we start shifting the graph, which we're not going to do yet. So I make myself a table, and when x is equal to 0, oh, can't be equal to 0. That's where my asymptote is. And then you'll need to know that this is also an asymptote. And now you can plot some points. 1 is going to give me -6. 2 is -3. 3 is -2. And just for kicks, I can do 6 because that'll give me -1. So 1, -6, 2, -3, 3, -2, 6, -1. That branch is really easy to see. But I still need to do the other branch. So if you want, you can just sit there and say -1, 6, -2, 3. For this one, just because it's going to come out the same. So -1, 6, -2, 3. That won't work so nicely when we start shifting them. -3, 2, and -6, 1. And why are we studying these? Because this is y is equal to -6 over x. These are the graphs of functions that are inversely proportional. So we were just studying inverse functions. That's why they're related. Okay. This is just from before, so I don't need to fill it in again. But now I have looks like a 0.5 there. That's a little annoying. So -1/2 over x, you really don't want a fraction in a fraction. So I'm going to change the bottom one to a fraction also so that I can keep the first one, change it to multiplication, and flip. So this is actually just -1 over 2x. I personally would rewrite it like that. So now when I go to make my table, does it change anything? No, x cannot be equal to 0. That is still going to be my vertical asymptote. And then you already have those filled in. And then at 1, I'm going to get -1/2. But at 2, I'm going to get -1/4. And then at 3, I'm going to get -1/6. Can you see where this is going? So at 1, -1/2. At 2, -1/4. 3, -1/6. Really hard to see. You would have to choose something like a half. Because think about what that would do. -1 over 2 times a half. Well, 2 times a half would make 1. So this would be -1. So when x is -1/2, you'd get -1. But luckily, we don't need to work that hard at it. Once you get a few points, even if they're not great points, you have the asymptotes that are really what drive the picture. And then, of course, you can go ahead and make more points for negatives. So if x is -1, then you get +1/2. When x is -2, you get +1/4. And you don't need to do more than that because the asymptotes will drive the graph. So -1/2, -2/4, and it looks like this. So we generally do put in the asymptotes as dashed lines. So my horizontal asymptote is going to stay until we start shifting at y is equal to 0. X and y are not equal to 0 until we shift. All right, see if you can switch that next one. I personally would rewrite this as 2/10 over x, but people struggle with that where they don't so much with a fraction and another fraction. So keep, change, flip. This is 2 over 10x, which I would reduce further to 1 over 5x. So I go ahead and I make my table. when x is 0, can't be 0. That reminds you that you're going to put your asymptote in. And even though it didn't create this one, you know it's there. And then 1 is going to be 1/5. So at 1, it's already really low. So even with just that 1 point, I mean, you could graph another one, but you can see it's really hard to graph. It's going to come down and it's going to go right through there. And then this one at -1, it's going to be -1/5. I could go to 2, but 2 is going to be 1/10. It's going to be even harder to draw. So even with just that 1 point in the asymptotes, you have a really good sense of what this looks like. And that's why people at first are a little intimidated by asymptotes, but I really like them because they really help you get a nice graph. Okay, so of course, what do we need to do? We need to shift. Luckily, it's just like everything else you've learned this year. The H is going to shift it left or right, and the K is going to shift it up or down. Nothing has changed. So when you do this problem, I personally would make your table of values for just 4/x. I would ignore the 2 and the 1 and just use those for shifting. So I go ahead and I make my table. Very easy to do, can't be 0. At 1, it's 4. At 2, it's 2. I'm not going to plug in 3. And then at 4, it's 1. And then continuing that with my negatives at -1, -4, -2, -2, and -4, -1. Second, use HK to translate the origin. So I'm going to go to the left 2. Remember, that one's always opposite. And then down 1. Gotta love math. It's so unchanging, right? So here's my new origin, which means if that's my origin, those are also my asymptotes, which is great. So what is this equation? All vertical lines are the equation x is equal to a number. In this case, x is equal to -2, which means that's the one number that x can't be, which should make sense. I know it looks here like we said it can't be 0, but we were using this easier function. But in all seriousness, if I put a -2 into here, the original, I will get a 0 in the denominator, which would be bad. According to my shift, the horizontal asymptote is now at y is equal to -1. And so my range, that's the one value that y will never be. Y is not equal to -1. And now I'm going to plot these points as if this were the origin. So 1, 4, and then 2, 2, and then 4, 1. I use my asymptotes as a guide, and I can make a really nice graph. -1, -4, -2, -2, -4, 1. Using my asymptotes as a guide. I hope you like these. I really like these. All right, see if you can do another one. So I want you to think of it as just y is equal to -2/x. I personally would make my chart that way. So you're not going to do anything at 0. 1 is -2. 2 is -1. -1 is 2. -2 is 1. That's really good enough. And then my shift is going to be left 1 and up 3. Left 1, up 3. That's my new origin. So that's also where my asymptotes are going to go. So my vertical asymptote is x is equal to -1. That means that my domain is x is never going to be -1. I'm not going to cross that. That is a wall. My horizontal asymptote is going to be a guideline, and that happens at y is equal to 3. That's its equation of that line. So it also means that my graph isn't going to touch it. So the range is y is not equal to 3. Now, I just want to point out that when you get to pre-calculus, we are going to do harder graphs where something might actually go through a horizontal asymptote. It actually might come up, and then go through it and then follow it. Remember that horizontal asymptotes always tell you the end behavior. They can be crossed. Can be crossed. So you might come up through the horizontal asymptote and then follow it. But the vertical ones are never crossed. You will never study a problem where you will cross a vertical asymptote. They are literally a wall. So from my origin, I'm going to do 1, -2, 2, -1. And I could do more points, but because I have the asymptotes, that's really enough to get a really nice graph. And then from here, -1, 2, -2, 1. And that's enough to give me a really nice graph. Okay, there are 4 more that I would really love for you to try on your own. If we were in school, I definitely would no longer be teaching. So if you want to turn off that video and try the next 4 and then skip ahead to the answers, that would be great. But of course, I am going to do it for you. So on this one, I'm just going to do y is equal to 3 over x. When x is 0, not possible. When x is 1, I get 3. When x is 3, I get 1. When x is -1, I get -3. And when x is -3, I mean, you could do 2 if you want to. It would give you 1.5. But this is easier. I'm going to shift just down 2. It doesn't go left or right at all. So when I only go down 2, here's my new origin. So here's going to be my horizontal asymptote, y is equal to -2. But my vertical asymptote is going to stay at x is equal to 0. Now I can plot my points, 1, 3, using this as my new origin, and then 3, 1. So I come down, and it should look like this. And then -1, -3, -3, -1. Do you see why I didn't feel I had to do -2 and then -1.5? I could do that, but I feel like I would have gone through that point even if I hadn't plotted it. That's really the benefit of asymptotes. It gives you a great shape without plotting as many points. Okay, on this next one, my first step would be to change this to just 1 over x. I do know that it's going to shift, but it's much easier to shift the entire graph and just make my table with these nice easy numbers. So x can't be 0. When it's 1, it's -1. At 2, it's -1/2. So there's no point in doing 3 and getting even smaller. -1 will be 1, and -2 will be +1/2. So this is going to shift to the left 4. 1, 2, 3, 4. That's going to be my new origin. And my asymptotes are going to be right here, the line y is equal to 0, and the line x is equal to -4. From my new origin, I'm going to plot 0, nothing, 1, -1, 2, -1/2, and that's all I need to know that it's going to go like that. I can get a great shape with just those 2 points. And on the other side, -1, 1, and -2, 1/2. Again, it's really all I need to get a great shape. If you still are watching me and haven't tried any on your own, I highly encourage you to see if you can do these next 2. So now this one is going to move to the right 1 and up 5. So right 1 and up 5, that's going to be my new origin. But when I make my table, I'm just going to use y is equal to 1 over x. I'm not going to include that -1 and that 5 at all. So 1, 1, 2, 1/2, -1, -1, -2, -1/2. I'm going to go ahead and draw my asymptotes in, which is y is equal to 5. And my vertical asymptote is going to be x is equal to 1. From there, I plot that point. And this point, I can't see very much of it, but that's all I need. And then this one, 1, negative 1, and negative 2, negative 1/2. Again, all I need to make a really great graph. Last one. I'm going to move this one to the left 4 and down 2, left 4 and down 2. I'm going to draw my asymptotes there. I didn't ask you to state the equation, but I will on a quiz. So y is equal to negative 2, and my vertical asymptote is x is equal to negative 4. And then from there, I'm going to make my table, but I'm only going to use y is equal to 2 over x. I'm going to ignore the 4 and the 2 while I'm making my table. So x is 0, not possible. 1, 2, 2, 1. That should be enough. So I skipped my negatives. Negative 1, negative 2, and negative 2, negative 1. And if you're thinking, wow, you make those tables really quickly, can I just do it in my head? You could do it in your head. That's because I'm not using the 4 and the 2. Think about how much harder it would be to make these tables with that. And that's why this is such a great system. So I go ahead and I plot from my new origin, 1, 2, and then 2, 1. And using my asymptotes in just those 2 points, I can make a really great graph. Negative 1, negative 2, and negative 2, negative 1. And it would look something like that. All right, the only thing left is for you to figure one out backwards. So I'm going to determine the values of h and k. So I can see that there's an asymptote here, and I can see there's an asymptote there. And once you've put in those asymptotes, you can find that center. So now I can see that it has gone to the left 1 and down 4. But remember that when you actually write your equation, it's going to be something over x plus 1. This one's the opposite. And then minus 4. Now, they didn't actually ask me to find a. That would be a little bit harder because I'd have to figure out, what these points were doing. Although this one is just a is equal to 1. So it didn't really matter. But we'll do that later in the chapter. But meanwhile, my h is equal to negative 1. And my k is equal to negative 4. All right, that is it for this set of notes on section 7.1 and 7.2. Have a great day.